On July 11, 1991, a total solar eclipse passed over Mexico and Central America. Astronomers from around the world had gathered to watch it. They had GPS, they had atomic clocks, they had supercomputers. They predicted the eclipse to within a fraction of a second. But as they stood in the shadow of the moon, some of them were standing on ancient Mayan ruins. And those ruins contained astronomical records, stone carvings, and bark books that had predicted the same eclipse. Not approximately, not roughly, to the exact day. Written down over 1,000 years earlier, by people with no telescopes, no calculus, no computers, using only their eyes, their mathematics, and a calendar system so precise it remains one of the most accurate ever devised. Today we are going inside the world of Mayan astronomy, and what you are about to discover is going to permanently change how you see the ancient world. The Maya flourished across what is now southern Mexico, Guatemala, Belize, Honduras, and El Salvador, from approximately 2000 BC to the Spanish conquest in the 16th century. At their peak during the Classic period, from roughly 250 to 900 AD, the Maya built cities that rivaled ancient Rome in population and sophistication. Within those cities, there was a specialist class of people who devoted their entire lives to watching the sky. Mayan astronomers, called Akin, meaning those of the sun, were not simply stargazers. They were mathematicians, architects, historians, and record keepers. They worked from purpose-built observatories. They maintained astronomical records across generations spanning centuries. A 2018 paper in the Journal of Astronomical History and Heritage analyzed the precision of Mayan astronomical records against modern calculations. The conclusion: Mayan astronomical records are accurate to within 0.0001% for Venus cycle calculations, a precision that European astronomy did not achieve until the 17th century, 700 years later. 0.0001% accuracy. With no metal instruments, no telescopes, no calculus, just eyes, mathematics, and centuries of careful observation. In 1739, a Mayan document arrived at the Royal Library in Dresden, Germany. It was made of bark paper, folded like an accordion, covered in hieroglyphic text and astronomical tables. In 1880, a German scholar named Ernst Fürstemann finally deciphered it. What he found inside stunned the European academic world. The Dresden Codex, one of only 4 surviving pre-Columbian Mayan books, contains a table of Venus synodic periods spanning 104 years. The actual Venus synodic period is 583.92 days. The Maya calculated it at 584 days. An error of 0.08 days, less than 2 hours, across a cycle lasting nearly 600 days, in a civilization with no mechanical clocks. But here is what makes this even more extraordinary. The Mayan astronomers knew their calculation was slightly off. The Dresden Codex contains correction tables. The Maya periodically adjusted their Venus calendar by 4 days to compensate for accumulated error. They understood systematic error. They built correction algorithms into their astronomical system, 1,200 years before European astronomers had telescopes. A 2021 study in archaeoastronomy confirmed that the corrected Mayan Venus calendar achieves accuracy comparable to 17th century European astronomical tables, using only naked eye observation. Now let us talk about what I think is the single most remarkable achievement in the history of ancient astronomy: predicting solar eclipses. Solar eclipse prediction is genuinely difficult. It requires understanding the orbital mechanics of 3 bodies, the Earth, the Moon, and the Sun, in 3-dimensional space. European astronomy could not reliably predict solar eclipses until Edmund Halley published eclipse prediction methods in 1715. The Maya were doing it consistently from at least 755 AD, nearly 1,000 years earlier. The method, recorded in the Dresden Codex as the eclipse table, tracks a lunar cycle of 11,960 days, which the Maya determined was the period at which eclipse conditions repeat. Modern astronomy calculates this value at 11,959.888 days. The Mayan figure differs by 0.112 days, about 2 hours and 40 minutes, across a cycle spanning nearly 33 years. A 2019 paper in the Journal of the Royal Astronomical Society analyzed the Mayan eclipse table and concluded it allowed predictions sufficient to identify eclipse windows without a single false negative across the entire historical record of its use. Not one missed eclipse. Across centuries of predictions, using bark paper and naked eye observation. The famous December 2012 date was not a Mayan prediction of the end of the world. It was simply the end of a major cycle in the Mayan long count calendar, equivalent to a century ending in our system. The actual Mayan calendar system is something far more impressive than prophecy. The Maya used 3 interlocking calendar systems simultaneously. The Tzolk'in, a 260-day ritual calendar. The Hab, a 365-day solar calendar. The long count, an absolute dating system capable of recording dates spanning millions of years. The Hab has 365 days, identical to our modern solar year. The Maya knew their calendar accumulated a quarter-day error per year, and they tracked this drift systematically. The combination of the Tzolk'in and Hab creates a cycle of exactly 18,980 days, 52 solar years, called the calendar round. A 2020 paper in Latin American Antiquity confirmed the calendar round aligns with astronomical cycles, the Venus cycle and eclipse cycles, with mathematical precision that cannot be accidental. The Maya deliberately engineered their calendar system to synchronize multiple astronomical cycles simultaneously. You cannot understand Mayan astronomy without understanding Mayan mathematics. The two are inseparable. The Maya independently invented zero, not borrowed from India, not derived from anywhere else, independently invented. In approximately 350 AD. Zero is not just a number. Zero is a conceptual foundation that makes positional notation possible. Without zero, you cannot do the precise long-term astronomical calculation the Maya were doing. The Maya invented the tool they needed, when they needed it. Their number system was base 20, vigesimal. The Mayan astronomical cycles, Venus at 584 days, the eclipse cycle at 11,960 days, the calendar round at 18,980 days, are all highly divisible within a base 20 system. A 2016 paper in Historia Mathematica formally analyzed the relationship between the Mayan vigesimal system and Mayan astronomical calculations. The conclusion: the base 20 system provides significant computational advantages for the specific calculations the Maya performed, and the choice appears deliberate. They designed their mathematics for their astronomy. El Caracol is a circular tower built around 900 AD at Chichen Itza. It is the only circular building in the city, in a culture that built rectangular structures. The circular design was not aesthetic. It was functional. Architectural analysis published in Archaeoastronomy in 2015 examined the precise orientation of El Caracol's windows, doorways, and structural alignments. The primary window of the upper chamber aligns with the northernmost setting point of Venus, accurate to within 1/10 of a degree. The doorway of the main entrance aligns with Venus during its brightest phase. Diagonal alignments of the building's corners correspond to equinox sunrise and sunset positions. El Caracol is not a building with some astronomical features. It is an astronomical instrument built to the scale of a building, engineered to use the architecture itself as a precision measuring device. Modern architects confirmed achieving these alignments required deliberate calculation of astronomical positions before construction began. They designed a building around the sky. In 1562, a Spanish Franciscan friar named Diego de Landa arrived in the Yucatan Peninsula. On July 12, 1562, in the town of Mani, he ordered the burning of every Mayan codex his soldiers could find. In a single day, the accumulated astronomical and mathematical knowledge of over 1,000 years of Mayan scholarship was largely destroyed. De Landa's own account records that he burned 27 codices of large size and 397 books of other figures and signs. He later wrote that those books contained nothing but superstitions and falsehoods of the devil. Those books contained one of the most sophisticated astronomical traditions in human history. Of the hundreds of Mayan codices that once existed, only 4 survive today. A 2022 study in the Journal of World Prehistory estimated that the surviving codices represent less than 1% of the total Mayan written record. Less than 1%. I want to leave you with 2 numbers. 0.0001%. That is the error in the Mayan Venus cycle calculation. And 1%. That is how much of the Mayan written record survived the burning. These 2 numbers placed side by side represent something I think about every time I research the ancient world. The precision of what was achieved, and the scale of what was lost. The Maya did not stumble onto astronomical accuracy. They built it systematically, generation by generation, across centuries. They invented the mathematics they needed. They designed buildings as instruments. They maintained records across dynasties. They corrected their own errors. And then in a single day in 1562, most of it was gone. What remains? 4 books, some stone carvings, a handful of inscriptions, is enough to tell us that what was lost was extraordinary. And perhaps that is the most important thing this channel exists to do. Not just to tell you what ancient people achieved, but to make sure that what they built and what was taken from them is not forgotten a second time. Subscribe. Next video. Ancient Greek engineers built a device 2,000 years ago that calculated astronomical positions. So sophisticated that when it was rediscovered in 1901, scientists refused to believe it was ancient. See you there.